So we have a 3-variable simultaneous equation in x, y, and z. So we've been given 3 variables, and because they give us 3 variables, we need to have 3 linear equations. The first thing we should do when we start a question like this is to just label each equation 1, 2, and 3. And the reason we do this is so that we don't lose track of our progress. As we work our way through the question, we have them numbered, and so we can go back and check our progress easily enough. This is the kind of question where people do make multiple mistakes because it is so long. And if you've labeled your equations, you can kind of, like I said, track back and see where the mistake might be made if you're not getting the correct answers. So we need to take 2 of these equations at a time and cancel the one letter. So we decide on what letter that is that we're going to eliminate from the equations. I can see that the z's are going to be quite tricky to eliminate. If I take equation 1 and 2, I'll have to try and turn them both into 6z's, the lowest common denominator of 3 and 2, and that involves multiplying both lines. Similarly, if I was to take equations 1 and 3, I would have to multiply one of the lines by 5 and the other line by -3. So again, I'm multiplying both of the lines. It looks to me like it will be easier to try and cancel the y's in this question. So I can see that if I multiplied the top line by 2, I'd have a -2y, and then that would cancel or eliminate the y's in equations 1 and 2. So I've decided on cancelling the y's, but you can pick whatever of the letters you want as long as you're consistent, and in both the equations, simultaneous equations we're about to do, you decide on the same letter to cancel. So I've selected equation 1 and equation 2, and like I said, I have to multiply equation 1 by 2 so that on the top line I have a -2y. So 3x by 2 is 6x, minus y by 2 is -2y, 3z by 2 is 6z, and 1 by 2 is 2. I'm not going to multiply equation 2 by anything, I'm going to leave that as it is. And now I can see that the -2y and the +2y, when I sum those together, I'll get 0. And so y will be eliminated from those 2 equations. So I'm going to sum the 2 lines. I draw a line underneath. I cancel the 2 y's. And then 6x plus x is 7x. 6z minus 2z is 4z. And then 2 minus 1 is 1. And we can't solve this equation yet. We have 2 variables. And so I can't find x and z yet. So what I'm going to have to do is I'm going to have to do that same system again and cancel the y's from a different set of 2 equations, and then I'm going to perform a simultaneous equation where I have 2 equations with x's and z's in them. So I'm going to just label that equation 4 before I move on, again just to keep track of my progress and so that everything is labeled and I can track back and make any corrections if I make mistakes. So now what I'm going to do is I'm going to collect equations 2 and 3 together and again eliminate y. So have a look up here and think about how could I eliminate the y's. Well, I would need again to multiply equation 3 by 2. And remember, when we say multiply an equation by 2, we need to multiply every term in that equation. So the second equation is going to stay the same, x plus 2y minus 2z equals -1. And then every term in equation 3 is going to get multiplied by 2. So 4x by 2 is 8x, minus y by 2 is -2y, 5z by 2 is 10z, and 4 by 2 is 8. I draw a line underneath, I cancel the y's, and I add down the rest. X plus 8x is 9x, minus 2z plus 10z is 8z, and minus 1 plus 8 is 7. And so I have another equation that has x's and z's, and I'm going to call this equation 5. So what you'll notice is, had I decided to take equation 2 and 3 and cancel the x's, maybe by multiplying the top line by 4, well, the problem is I would have had an equation underneath that would have had y's and z's in it. And an equation with y's and z's can't be used in conjunction with an equation that has x's and z's. So that's why you have to be consistent, and whatever letter you decide to eliminate, you need to use or eliminate that same letter each time you do the simultaneous equations. So what I'm going to do is I'm going to now take equation 4 and 5 and try and eliminate either the x's or the z's. So a quick look at it tells me that if I multiply equation 4 by -2, this 4z would turn into a -8z, and it would cancel with the 8z down here. So that's exactly what I'm going to do. I'm going to multiply equation 4 by -2. So 7x by -2 is -14x. 4z times -2 is -8z, and 1 by -2 is -2. 9x plus 8z equals 7, equation 5, I'm going to leave as it is. I'm going to draw a line underneath, I'm going to cancel the 8z's, and minus 14x plus 9x is minus 5x, and minus 2 plus 7 is 5. I divide both sides by minus 5. Minus 5x divided by minus 5 is x, and 5 divided by minus 5 is minus 1. And so we have our first solution, x is equal to minus 1. Well, now that I know that x is equal to minus 1, I can sub this back into equation 4 or 5 to find out what z is. It won't be any use subbing this back into equations 1, 2, or 3, because if I do that, I'll eliminate the x's, but I'll still have y's and z's, and so I won't be able to solve that equation. So I need to sub it back into either of the two equations where we just have x's and z's. So I've decided I'm going to sub it back into equation 4. And so I write down equation 4, 7x plus 4z equals 1. I now know that x is equal to minus 1, so I'm going to sub that in. 7 times minus 1 is minus 7 plus 4z equals 1. I'm going to add a 7 to both sides to get rid of the minus 7 from the left, so 4z is equal to 8. And I'm going to divide both sides by 4 to give me that z is equal to 2. Now I have that x equals minus 1 and z equals 2. So because I have two of the three unknown variables, what I'm going to do is I'm going to sub these two variables into either of the three original equations. So it doesn't really matter which equation we sub it back into. So we may as well just select equation 1. And so we write down equation 1 again. 3x minus y plus 3z equals 1. We know that x is minus 1 and z is 2. So I'm going to sub both of those in. 3 times minus 1 is minus 3. Minus y. 3 times 2 is 6 is equal to 1. I'm going to collect the y terms on the left and the number terms on the right, and I get eventually that y is equal to 2. And so we've solved the three variable simultaneous equation. We have x is minus 1, y is equal to 2, and z is equal to 2. And if we want to check these answers, we can take either of the three original equations and we can sub each of those in. So that's just one of a number of possible solutions to that equation. I decided to eliminate the y's. I could equally have eliminated the z's or the x's. To quickly look at how we might have done the x's, I could have taken equation 1 and 2 and multiplied equation 2 by minus 3. We would have had minus 3x at the start, the x's would have eliminated, and I would have an equation with y's and z's. I could have then come along and taken equation 2 and 3 and multiplied equation 2 by minus 4 this time, and then I would have minus 4x, the x's would have eliminated, and I would have had another equation with y's and z's, and I would have solved for either y or z. So it doesn't matter which of the letters you choose to eliminate, just as long as you're consistent, and whatever letter you pick, you do the same thing for your first set of simultaneous equations and your second set of simultaneous equations.